Okay, some of you might have attended my talk at GCamp. There is going to be a repeat talk of the same because I don't think many of you attended. How many of you have attended this? Oh, only one? Okay. Okay, that means I think it would be interesting. I need about 40-45 minutes to finish this. Get started. I hope you know about me. My second edition of the book is complete. It's available for pre-order. I'll show the links later. Okay, how many of you are iOS developers here? I think everyone. And how many of you have done server development before? Okay, that's good. This talk is going to be for both iOS developers and server developers. It will be useful for both iOS developers and server developers. And I'll be talking about how to build a server that works effectively with a disconnected mobile client. A web client is connected, is kind of bound together so that the app behaves more responsibly. Okay. First thing is get, post, put, and delete. Right? It's kind of easy to understand by looking at the meaning, but people don't use it that way. I've seen a lot of server APIs where every call is a get. The reason is it can be easily simulated by typing the URL on the browser. But there are problems when you do that. Okay, we'll come to the problems later. So this is how it should be done. Any API that changes your database should be a put or post. It's a post if it alters it, it's a put if it adds it. And any API that deletes it should be a delete. And anything that retrieves data from your database is a get. Simple. It should not be used in any other wrong way. Okay? Because put and post are called as idempotent operations. We'll come to that later. In developer parlance, if you're going to write an insert query, it should be post. If you're going to write an update query, it should be put. If you're going to write a delete query, it's delete. And finally get for select. It's as simple as that. Most of your languages allows you to change the verb easily, right? Most of the languages allows you to change the routing table, where you probably maintain a list of verbs for each URL. You should probably use the right URL, and it has implications later. I've seen a lot of SOAP developers doing it the wrong way. In SOAP, everything is a post, and you pass the action that you want to perform in a variable called SOAP action. Right? So what happens if you want to retrieve data from a database? It's a SOAP call, it's a post call to your server that retrieves data and comes back to you. If you implement it as a get call, your proxy servers can cache it, which means subsequent call from the same guy or from someone else will not even hit your server. You get free load balancing just by using the right verb. Right? If you do it this way, like a remote procedure call way or the SOAP way, you won't get those benefits. And HTTP is built, the whole internet is built on top of HTTP, right? A wrong usage of verbs will easily prevent you from scaling. And this is how people do it. You know, api.mycompany.com/api.service, and then you usually have a parameter called OP equal to what? There's one single endpoint, everything is a parameter. First thing, caching. You will miss caching benefits if you don't use gets for everything. When you interact with the server, the 80-20 rule applies. 80% of your calls are going to retrieve data, and 20% of your calls are going to post data. For example, Facebook. How often do you update status and how often do you read your friend's newsfeed? and how often you add comment and how often do you read comments. It's approximately 80-20, right? So 80% of the time, if you're going to read news feeds, if someone can cache it in between, it's good for you, right? So as far as possible, if there is no database change, try to use the get verb. A get verb can cache it, can allow intermediate proxies to cache it. And why doesn't intermediate proxies cache post? Because post is a non-idempotent operation. You have to repeat post calls when the browser or when the client asks you to repeat it. Because post input can technically alter the state of the database. Some of the browsers show you this prompt, right? Are you sure you want to submit this form again? This could cause a duplicate purchase or duplicate charges on your credit card. You might have seen this kind of dialogues, right? This is because it's a post call. When a form post is accidentally made twice, the browser wants a reconfirmation from you instead of showing a cached or stale data. None of the browsers or none of the intermediate proxies are instructed to cache post or put calls. This is a HTTP standard, HTTP caching standard. I'll come to that later. Yeah, I think I covered this. Just by using a get verb, you get caching benefits very easily. And then there's something called PTOS and pure RESTful server. You know, when you talk about RESTful implementation, there are always going to be purists who come to you and say, hey, this is not as per Roy Fielding's thesis, etc., etc. There's nothing pure in this world. There's no pure object-oriented programming language that is useful. Pure RESTful server. Don't try to achieve a pure RESTful server implementation. That probably takes a long time to implement. And when your majority of consumers are on a mobile device, it might not be necessary because your iPhone app is not a RESTful client. A browser is a RESTful client. Okay, I can't explain what is RESTful right now. Maybe I'll start. A RESTful client, a RESTful server serves hypermedia resource. And what is a hypermedia resource? A resource that contains links to other pages or links to other events or actions is called as a hypermedia resource. Okay. A HTML page is a hypermedia resource. XHTML page is a hypermedia resource. JSON is not a hypermedia resource. Unless you add your own href keys and href values and you make it, you add URLs manually, it's not a hypermedia resource. And when JSON is going to be the language that the encoding type you're going to use, obviously you're not going to make a RESTful server. Second thing, a RESTful server sends forms to the client and expects the client to click on those forms. This kind of something that is impossible on a mobile environment, mobile client which is kind of disconnected from your server. Right? A RESTful server on a web will send you a form and the form is clicked. The end user does not know anything, doesn't have to know anything about the URL it gets posted to. Right? Lastly, your iOS app should be complete in 3 months. Any iOS app, however complex it is, it has to be complete in 3 months. Reason? Competition. Second, if you wait anything more than 3 months, Apple is going to update their operating system, add new features. Sometimes some of their features might overlap with what you're doing. Sometimes they'll change certain SDK, certain implementation that makes a lot of rework on your end. So if you keep delaying your release by more than 3 or 4 months, you'll never complete the project. It's not like Java where, Java, they update their SDKs every 3 years or something, and releases on Ruby, I'm not sure how often it is, but usually it's not every year. No other platform update their software by this extent every year, right? So this is very important when you're building an iPhone app, iPhone or iPad app. And RESTful implementation were kind of nice to have when browser was the dominant consuming platform. But today, the most dominant consuming platform is going to be your native app, right? Which is not RESTful, which is not a RESTful client anyway. And lastly, in Web 2.0 era, the race was to make your app work on a majority of browsers so that you get a lot of users, right? Today the race is about how to make a curated, customized, beautiful app that's better than my competitor, right? So a curated experience versus a generic experience, that is kind of against the RESTful criteria. That completes the first part. We'll talk about documentation. First thing when you are asked to document an API, is identify your top level models. Okay? Don't document URLs, parameters and responses. That's not going to help anyone because you'll be changing your responses quite often. Whenever you change your columns in your database, you're going to change responses in your output, right? So don't just document, hey, this is the URL, this is what you have to call, and this is the parameters you have to pass, and this is the output. Don't do that. Instead, document your top level models. For example, if you go to Foursquare documentation, you will see a list of top level models they use. Venues. Whenever API method returns a venue, it's going to contain all these parameters. Whenever an API method is going to return a user's profile, it's going to contain all these fields. And that's how you should start thinking. In your app, what will be your top level model? Start thinking that first. Document your top level model and then start writing your URL routes. And second thing, top level models are not your database tables. They are different. I'll come back to this a couple of slides later. Every top level model might have one or more DAO, assuming you use a relational database instead of a NoSQL database. Example, a tweet is a top level model, but it could contain a user profile and the tweet string. Right? So a top level model is a tweet, but how it's stored in database is different. It's stored as a the tweet string might be stored in a different table. The user's profile will be stored in a different table. But when I get a tweet from Twitter, it gives me everything, right? And that is kind of a crude difference between a top level model and a database object. Second step is to document your URL routes and mark mandatory and optional parameters. List public, protected, and hybrid API. Okay, what is a hybrid API? Public, you know that you don't need authentication or you don't need to pass a HTTP auth headers to get information from a public API. Right? Protected is an API that prevents you from accessing any kind of information till you pass a valid auth parameter. If you don't pass, if your arguments, if your authorization header is invalid, it says a 401 unauthorized error. Right? Hybrid APIs are different. If you pass an authorization header, you get information. If you don't pass, you'll get anything that is available publicly. Okay? For example, tweet. When you access a tweet of a protected user account, you cannot see it without passing an authorization token. Facebook user profile. You cannot see the entire Facebook user profile of a user without passing an auth credential. But if you don't pass it, you see a very basic profile about that person which is public. Right? Like for example, you go to facebook.com/a person name, you can see a very brief profile of that person. Right? But if you're logged in, you see a lot more information about him. Depending on your relation with that person. If he is a friend, you see more information. If you're subscribing to his feeds, you see slightly lesser information. If you don't know him, it's going to be the same as public information, right? So hybrid APIs behave like that. there are certain APIs that will behave, that will send you more information about a particular top level model when you pass an authorization credential. For example, tweets. When I'm logged in, I know the geolocation of the tweet. When I'm not logged in, don't send it. Something like that. I'm not sure if Twitter implements it, but something similar to that. Private information, privacy related information are usually should not be sent without an auth header. Document your API responses using these top level models. Foursquare does this. /venues/venue ID will return you a venue object, a venue resource, and that's how they document it. They don't document a whole JSON payload that no one can understand. Okay. Say that this is the API. If you pass these parameters, you will get this resource as the output. Okay. That means when you are changing a venue model because of a business decision, all the APIs can be updated at one shot by just updating the model, right? Lastly, APIs should not have undocumented behavior. And what I mean by this is, if you are allowing a user to access a protected data, you should validate every single parameter that is passed. You should never have a else clause in your if statements. Okay? If gender equal to male, send this information, else send this information. That assumes that if I pass anything apart from male, I'm going to get all the female information. That's not the right way to do it. Anyone can play around with your API parameters to sniff data from your site. Right? Validate every single parameter, and if parameters are invalid, throw an error. Another example is if one of your parameter accepts 3 or 4 choices. Okay? For example, say profile type equal to public. This can take 3 values, say public, protected, and private. Okay? If this is the case, you have to validate whether the profile type is one of these 3. If it is not one of these 3, you have to throw an error. Because the user could pass any junk value into it to get your else component of your response. You shouldn't do something like if public, do this. Else if private, do this. Else, do this. If you do that, if you implement something like that in your server code, I can pass nonsense to that parameter and get information out of your server, which could be a protected private information of someone, right? Shouldn't do that. Any non-essential parameter of an API should be passed on the HTTP header, like access token. You shouldn't pass access token on URL strings or a suppose parameter for every call. This is going to be there for every single call, right? So you should ask the client implementers to pass it on the HTTP headers. Okay, and if it is a custom header, you can prefix it with X client identifier equal to whatever X client ID, client token, client whatever. Authorization header should be passed on HTTP's authorization. HTTP has a header field called authorization, and if the server sends that header, your browser normally shows a dialog asking you for a username and password, right? And when the HTTP header sent by the server is www authenticate, you see a sheet on browser, right? That's how your client should also behave. On iOS, this behavior is built in. On other platforms, you have to bake it in on your code. A good example is Foursquare API. Another example is app.net, which is this Twitter competitor. Yeah, their API is like this. /venue. If you call api.foursquare.com/venue/venue ID, it returns a detailed venue object, and that's how they have documented it. They don't say what is that detailed venue object, but just show a hyperlink. You click on the hyperlink, it takes you to the list of parameters, the list of fields that a venue model contains. Okay. App.net is also good. Twitter is also good, but very extensive at this point of time. They've grown big and massive. It's quite difficult to understand as well at this point of time. You can probably go through Foursquare first and then app.net and then come to Twitter to get an idea of how to build a good API server and documentation for that. And none of these are pure RESTful implementation. They are all good API servers. I told you that DAO is not same as top level models, right? These are the differences. For Twitter, tweet is a top level model. Right? If you're using a relational database, assuming that you're using a relational database, a tweet will be stored. A tweet would be stored in a tweets table. The geolocation of tweet would probably be stored in some other table, which is foreign key referenced back to this tweet table. The user who tweeted will be on another table called user, and again foreign key reference back to this table. The number of people who retweeted comes from another table. Top 10 users who tweeted again comes from another table. So for getting a tweet from Twitter, the API has to talk to 5 different tables, right? So to prepare this resource model from all these 5 tables is the responsibility of the API developer. Okay, I'll show you what happens if this is not done this way. This is how it's stored in a table. API that is denormalized will send you one single tweet information in one call. When you make a call to Foursquare to get venue information, you get venue, you get who is the mayor for the venue, including a very small information about the user profile, a link to his picture, and you get information about their opening hours, closing hours. You get a list of people who have visited that place often, or some other information like that. They are all stored on different tables on the backend, but the API server takes care of denormalizing them and putting it together in one resource. Right? If you don't do that, it affects scaling and performance of the client app very badly. I'll show you an example. When you do database design, you normalize your database, right? You normalize your database, you split your data and store it in multiple databases, index your columns properly, and ensure that your database is flexible enough for changes. Right? When you normalize it, you should denormalize it back. When you get input from a web-based form, it's just one single form. But when you store it, you normalize it, right? Similarly, when you bring it back to an API, you should denormalize it. And a majority of developers don't do this. A majority of them don't do this, won't do this. Probably because it's not done that way in web development. A JavaScript client or a web-based client does not require a resource or a complete resource package, and probably because this developer would not have enough experience to do it. But most of the good, well-developed APIs like Facebook Graph API or Twitter's API, Foursquare or app.net API, they do denormalization of their API. API denormalization is as important as your database normalization. It's the reverse process of database normalization. Right? If you don't do it, this happens. The client has to make multiple calls to the server to get the same information that they could get in one single call. I'll show you an example. This is a tweet, right? This is a tweet page. This part is my user profile. This is the tweet text. This is the number of retweets and favorites. If you don't denormalize, when a client implements this view, the first call should be made to the user's API to get the user information. Second call has to be made to get the tweet information. third call to get the number of retweets, and fourth call to get number of favorites. So what could be completed in one call now takes 4 different calls. And what that means is, if your server can handle, say 10,000 calls a minute, just by improper denormalization, you effectively reduce your server's capacity by 4. Right? And when that happens, your sysadmin is going to do this. There's something called keep alive on Nginx headers or Apache headers that tells you, that instructs a client how long a socket connection should be kept open. Of course, HTTP is implemented on top of TCP sockets, right? And a HTTP server like Apache or Nginx, they instruct a browser to keep the connection open for the next 15 seconds. If keep alive is 15, the browser keeps the connection open for the next 15 seconds and reuses the same connection when you refresh your browser or when you click on some other link on the same website, on the same host, right? To improve your scalability, keep alive is usually kept low. The default on Apache 2.2 is 4 seconds, if I'm not wrong. And when you have scaling problems, your sysadmin will set it to 0. And what 0 means is, every 4 calls is going to create a new connection, new socket connection with your server. And what that means is, every call takes bandwidth time plus ping time. And ping on 3G networks is like 250 milliseconds or 300 milliseconds if you are connected to a good 3G network. If you are underground, it could be 2 or 3 seconds. And loading this whole page will take like 15-20 seconds if you don't denormalize it properly. So it affects your scalability, it affects your UI performance. Lastly, 3G networks, most of the providers, they throttle the number of concurrent connections. On a broadband, you can have up to 6 concurrent connections to a server, right? HTTP. It's HTTP's limit. But on a 3G, your Singtel or StarHub, they're going to throttle it to 2 on a 3G network. On Edge, it's usually 1. This kind of norm, unwritten rule on most of the networks throughout the world, right? And when this throttling happens, your app is going to struggle a lot. If I can open only 2 connections, when these 2 parts is being loaded, I won't be able to show any information about this. This call will be queued and will be executed only after the first 2 parts are loaded completely. And that kills your server, that kills your client user experience badly. So as far as possible, whenever you design a API, try to send as much of information as possible to the client in one go. So if the client calls one API or one URL, try to send as much information as possible. It's not like Ajax. In Ajax, you have a background request for this, you have a background request for this, you have a background request for every single part of your divs, and it all loads well because you are allowed to open 6 concurrent connections in parallel, and your laptop or your desktop is going to be connected to a very good low latency Wi-Fi network, and it all works. But on iPhone, it's not going to work. On iPhone or Android, it's not going to work. Especially when you're connected to an edge network, it's going to be even worse. It's not just data bandwidth limitation, it's ping time as well. Every connection, if you keep alive is 0, every connection requires a ping time. 250 milliseconds additional. Yeah, this happens. Your sysadmin goes and reduces your keep alive to 0, and it appears as if it's working for first few 30 minutes or something, and then goes down again. Yeah, a denormalized API will kill your startup when you are kind of exploding, when you're going in that exponential curve. You won't be able to scale properly if your API is not denormalized, because it's a scaling complexity that only engineers can solve, not your sysadmins, right? So when these kind of scaling problems should be built into your product. It's not something that is, hey, spin 2 or 3 more AWS instances. Not going to help. It's a kind of stopgap measure. Cellular networks even in 2012 has this problem. Just 2 connections, that's all. You try to open third, it's going to wait till the first and second is complete. Broadband is good. Your home broadband is good. If you use softwares like download managers, you can kind of queue up to 6 concurrent connections to one server, download whatever you want. But mobile networks are completely different. This is very important when your app is a web service based app. You want the web service based app to behave as if every content is on the device, right? As if every content is local, right? Only a proper denormalized API can help you do that. Last but one, versioning. Why is versioning important? Anyone? Okay. When you're making a web-based application, you have the control over the client deployment. Right? When you change something on the server, you change something on your JavaScript code, ensure that your front end works well with your back end, and you deploy it together. Right? But iPhone is not like that. You have to deploy your server, and then submit the app to Apple, and then Apple approves it. And it's up to the user to update the app at whatever time they want. Right? How many of you have more than 10 updates on your App Store icon? I have it. Most of them don't update their apps. Right? Because of this, your users are going to hit your 2.0 server with 1.0 client. Right? There could be multiple versions of client accessing the same server. And this causes trouble because there's only one database. Database is not version. There's one database, multiple API servers. There should be someone in between to manage and to kind of properly switch all requests back to one single database, right? And that is the responsibility of the API server. You can't just copy your PHP code, call it V1, and then call another code base as V2, deploy it separately, and ask the client developer to call this directly. At the end, your backend your database is just one. You don't have multiple databases, right? Even your V2 code is going to call the same database. It has to update the same database. And that causes a lot of trouble if you use multiple deployments tied to the same code base. It wasn't a problem with web-based applications. Native clients are disconnected from your server. You cannot deploy all native clients at one go, unlike a JavaScript client or unlike a web client, where you deploy your web application and your server code at the same time. I'll give you an example. Version 1, you have a model called profile, and because we all make mistakes, we didn't use first name and last name. Okay? We sent the complete name as one single key called name. In version 2, business requirements changed. Probably they are moving their business to Japan or something where showing last name is considered. Showing first name is considered not so respectful. So clients should be able to hide the first name and show only the last name. So your client implementer is going to expect something like this. The client implementer is going to expect a separate first name and separate last name. If you do send just this, if you change your API to send just this, when version 1.0 of the app talks to your server and opens the profile page, he won't see anything. He'll see a blank name, right? Because version 1 expects the key to be named. Version 2 expects the key to be first name and last name. So when you have both version 1 client and version 2 client talking to the same API server, you have to somehow send this to the first request coming from version 1.0 of your client, and this to the second request coming from a newer client, right? What most people do is something like this. They merge everything into one single packet and send it. Right? This is wrong. The reason is, when you do that, you won't have control over deprecation. You won't know when I merged these two models. You won't, like after 5 versions are released, you won't know why I'm still using name. You won't know why I'm still using this particular key anymore, right? So, which means you won't be able to deprecate your API at one point of time. Like Twitter says, from this date, I'm not going to support this API at all anymore, right? That kind of control you won't have with your API. The right way to do it is using model-based versioning. We talked about top-level models, right? You should always model your version, or you should always version your top-level models. And what that means is, when I request venue model from a 1.0 client, you should send me 1.0. The API should automatically send version 1.0 of the model. If the same request comes from 2.0 client, it should send 2.0 version of the same model. And I'll show you how to do that. Okay? Yes. Maintain multiple models in your code. If it is Ruby, probably I don't know if Ruby has namespaces. On Java, what we do is we create namespaces. On Java C# what we do is we create namespaces, call it as version 1, call it as version 2, and create models inside those namespaces. And respect your accept header. The accept header in your that comes from your client identifies the client. So you'll know whether it's a 1.0 client or 2.0 client from this accept header. HTTP accepts header. And by seeing that value, you should instantiate the right kind of top-level model. After you instantiate that model, fill it in with the information from your database tables. I told you that DAO objects are not equal to top-level models, right? When you have that separation, when you separate your top-level models, abstract it away from your database models, you can do versioning easily. You can have multiple versions of your top-level models connected to the same database, in the constructor or in whatever factory methods, populate this version of the top-level model with whatever information is available on the database, send it back to the client. Don't use URL versioning. Avoid using URL versioning. You can use URL versions if you are completely going to deprecate version 1.0 altogether. This is how a model-based accept header looks like. Okay. This is a standard HTTP standard. You say, I'm going to accept application/XML, or I'm going to accept application/JSON. Right? When you want the server to send only JSON, you say, I accept only application/JSON. Right? Similarly, when you want the server to know that I accept only venue model 1.0, you say something like application/foursquare.venue.1.0 plus JSON. So when the server sees it, it should instantiate venue model 1.0, fill in the information, whatever information is available for that model from the database, send it. And when you cannot fulfill your model with information from the database, you duplicate it. Is that clear? When you cannot fill a model with the right kind of information from what you have in your database, you duplicate it. Yeah, and this is possible if you do proper denormalization. You have one top-level model, information coming in from multiple database tables into this model, and you serialize that model and send it out. Yeah. Serialize version 1 if the accept header says version 1. Serialize version 2 if your accept header is version 2. And what this means is, if you document and if the client implementer completes this implementation, it's not going to change forever. Even if you change your database table, it will affect only subsequent versions, right? Because you are honoring accept headers from now. First reason to do model versioning is database is going to change often. Whenever business requirements change, you first touch your database, right? You cannot prevent database change at all. The database is going to have new tables, new columns, new indexes, and this should not affect the response that you committed to the client implementer, right? You said, I'm going to send first name and last name. You should not remove altogether at one point of time, right? So this ensures that does not happen because you version top-level models separately, fill in information from your database. You have a kind of abstraction, kind of separation of concern. Right? The second most important point is the server developer will have, as a server developer, you will have complete control over when to deprecate your models and when to deprecate your API. So if all the clients are already on 2.0, I can throw away my profile 1.0 version. I can delete the namespace completely. You do this when you cannot meaningfully accommodate the information from your database into a model. Like the model has changed a lot over a period of time, and your version 1.0 model cannot be filled with whatever information you have. And when you reach that point, you deprecate it. Changes to database can be done without affecting your response, without affecting the response of your API. And what that means is your startup can be nimble. Whenever business owners want to make a change, they can easily make without affecting anything, because there's clear separation of concerns. You denormalize it, you have proper top-level models, and that separation of concern allows you to be even more flexible and nimble. And that is very important if you are a startup. There will be a lot of pivots, there will be a lot of changes to the track you're going. Right? I've seen a lot of PHP code like this. How many of you have seen something like this? You ask for user.php, question mark, user ID equal to something. The response will be select star from user, where user ID equal to $_get that parameter. Get the response, JSON encode, that's all. The problem is it's denormalized. It's not denormalized. It sends the normalized database information to the response. You add a column, because of the star, that column gets inserted into your payload, response payload. You delete a column, it's not going to appear on the payload at all. Every change in database affects the client developer, and that's not proper model view controller abstraction at all, right? Of course, sometimes it won't be this simple. The query would probably be a view or something that has even more information packed. This is a kind of crude abstraction of how sometimes people do. This is completely wrong. Last is caching. Oh, I'm almost done. Someone tweeted this, I don't know who is this. He says, there are two rules for caching. If you add a caching layer to your application, it becomes erratic. If you don't add, you can't scale it. It's like, add something like CouchDB plug CouchDB into your application. It behaves well, but there'll be synchronization issues between cache and your database. Your cache DB will have some information, your real DB will have some other information, right? So caching is hard if you try to invent your own caching schemes. The good news is HTTP dictates what every client should cache. Okay, your browser has a cache, right? And how does a browser decide which page to cache and how long this page should be cached? It's dictated by the server. The server says, I can approximately tell that this page should be kept for next 7 days. This page won't be changing for the next 7 days. And if that information is coming to the client, to the browser caches it for the next 7 days. I'll show you an example. Okay, I'll come to this slide later. Okay. How many of you have played around with Nginx header, configuration header, or Apache's configuration header? You would have done something like this, right? And this says, from my home directory, any of these files should be cached for 7 days. And what this means is, Nginx application converts this to an equivalent HTTP header that directs the browser to cache it for 7 days. Okay? If your sysadmin is doing this, the client implementer should obey this. If the sysadmin says expire it every 3 days, the client should expire it every 3 days. It shouldn't be some disjoint business logic which some people do, like, yeah. I've seen a lot of open source code on GitHub in Objective-C that does this. Image cache toolkits. Okay, what they do is they download the image, cache it in your caches directory, and empty this cache directory every 7 days or every 3 days. If the next launch time is more than 7, empty it. The problem is the client has control over cache revalidation or cache expiry. In this case, it's 7 days, right? You're hard coding 7 days in your client and not respecting Nginx configuration, right? So what happens? Changes made to an avatar will not be visible for another user for the next 7 days. Assuming Facebook, I update my avatar picture, but before I update, he is a friend of mine and his device has cached my old picture. He won't see the new picture for the next 7 days because his device does not know where to refetch the same image. It shows the old stale image for the next 6 days till it is deleted by the local caching mechanism. Right? HTTP has standards to overcome all this. Another problem that could happen is you have a update page, you update your profile image on the update page, close it, come back to any other page, still see the older picture. Right? Or on Android or iPhone, how many of you have come across this situation? You have a profile update or you have a photo upload page, you make some changes to the photo, come back to your stream or come back to your profile page, you still see the old page, old cached image. Right? That happens because you're trying to reinvent your own caching mechanism. You're not depending on HTTP's caching mechanism that has been in use for the past 15 or 20 years, that has been proven and is successfully used in browsers for the past several decades. The standards dictate two important models. One is an expiration model and one is a validation model. Expiration model is what I showed you just now. This particular resource expires in 7 days. That is an expiration model cache. So it's normally used for static files. The other model is validation model. Validation model is like the client asks, hey, I have this version of, I have a picture as on 28th February. Do you have any update after that? The server sends an update if it has, or if it does not have an update, it sends a 304 not modified. Right? And if there is an update, you delete your cached file, re-download it, recache it, resave it. This is what when you set something like this in your Nginx config, Nginx application converts it to something like this. Expires after the date will be today plus 7. Okay. Validation model is slightly trickier to implement. It uses checksums of the resource. So Amazon S3 uses validation model for resources inside S3 buckets. So if you store profile images inside your S3 bucket, they hash it, send the hash of the image along with every request you make to that page. And this hash is usually sent on the header file called etag. And this is again a standard. So what the client does is, it downloads, saves it to the cache, tag it with this etag. Next time when the same image is requested, it makes a request to the client saying that, hey, this is the etag I have. Do you have an update after this? If the server has an update, it sends the new profile image or new whatever image. Another validation mechanism is using last modified. Every database or every master table in your database has a field called last modified, right? How many of you are database developers? Like, how many of you have written stored procedures or played around with databases? Most of you, right? You will always have a last modified in your database table, right? Have you ever used it? Apart from using it for some var queries, from select queries, the reason why database tables have last modified is when a request to that resource is made, you have to know when the request was last modified on the server. For example, if I update the profile today on Facebook, they update the last modified to this date. When a client requests for my profile, and if the date is after the last modified date, there's no necessity to resend the same information again, right? And that is why you use last modified on most of your master table in your database. And you use this last modified to compute whether there was a change in your database model. If there is no change, send a 304 not modified. Don't send the same information again. Client validation works like this. There is a header called if modified since. And how this works is, I know the last modified date of this resource. Do you have an update after this? So if modified since 28th February, send me the information. So the server checks this value, sends the information only if it has been changed. If it is not changed, it sends a 304 not modified. You effectively save bandwidth, which means, again, engineering scalability. And the other field that is often used is if none match. If modified since is used if you have a last modified field, if it is like images and you don't have last modified field and you're depending on checksums, you ask the server to send if the checksum is different. Okay. ETAG based caching is easy to implement. You normally hash your top level models. Okay. So if I ask for a tweet, you prepare the top level model, hash it, and send the object hash of that tweet as the ETAG. And when the same request was made again, create the same tweet model, hash it again. If the checksum matches, don't send it again. Send a 304 not modified. Last modified is slightly different. You have to check the database.
Sorry to interrupt. Can I ask a question?
Yeah, sure.
So you're mentioning hashing the top level database model.
Right.
How do I actually implement this ETAG model for the denormalized data and send back to the client?
Normalized top level models, like if it is most of your object-oriented programming languages, your top level model is going to be inherited from, say, Java or Clang.object, or if it is C# with system.object or whatever, right? This object class has a method called hash. And Ruby also should have something equal.
Sorry, no. The question is, how do I square the idea of a object level hash on the model in the database with a denormalized packet of data sending back to the client?
When you're using ETAGs, the database DAO objects does not have a hash at all. Database has a last modified field alone. When you use ETAG based hashing, you send the hash of the top level model. Okay? And when you're using last modified, you will send the last modified of the resource of the complete top level model. And that is the last modified field of whichever is greater among the corresponding database table. For example, if it is a tweet, and if a tweet information comes from four different database tables, the last modified date of this tweet is the latest date of all these four database tables. Like for example, if the tweet text is modified on 1st of March, if the profile information was updated on 2nd of March, if the number of retweets was changed, someone else retweeted on 3rd of March, and so the number of retweets changed on 3rd of March, favorites changed 4th of March, the whole tweet objects last modified is 4th of March. Okay, last modified is the least, the lowest value of all the composite elements within that model. Hash is generic object hash. Most of your programming languages have object hashing algorithms, right? I don't know what Ruby, but Java has it, C# has it, and don't know what PHP too. Yeah. The good part, if you use last modified, is if you have a query called select star from friends, it becomes something like select star from friends, where friended date is greater than if modified since. So it's like this: the iPhone client has your list of 100 friends, and this was fetched on 3rd of March. Today is 6th of March, and you got 2 new friends added, right? So the iPhone client makes a request saying, I have the first 100 list as on this date. Send me if there are new friends added after this date. And your query becomes something like this. And what that means is you're not going to send the same 100 list again and again to the client. Your payload is lower. Your payload is lower, bandwidth is lower, optimized use of bandwidth, and again, indirectly bubbles back to higher scalability. And this is a kind of thumb rule that you should be using. All static models use expiration model, like JPEG files, PNG files, expire after 7 days, something like that. Any dynamic generated data should be validated from the server. And if the dynamic data is a list, like list of friends, use last modified and send only the diff when the client makes a request again. It gets slightly complex if your list gets deleted entries. So you have 100 friends, you block 3 of them, and you get 2 new friends. So you have to say that, hey, these 3 friends are blocked, and these 3 are new. And it's slightly more complex to implement when you have when this list has deletions, blocking, unfollow, and all those mechanisms. But when you do it, it optimizes bandwidth use, and it optimizes the frequency in which your server is getting hit. Right? So in most cases, it will be like, how often do you get a new friend on Facebook? Once in 1 or 2 days, or sometimes 1 or 2 weeks. So if a repeated request is made from the client Facebook app, more than 80% of the time you're going to send 3.4 not modified. Hey, the friends list was not modified at all since you had the latest version. So that is a kind of optimization that you should try to reach with your APIs. That's all. These are the resources. There's a very good book on how to build your REST API servers. It's actually quite small, about 150 pages or 200 pages, something like that. I wrote a couple of articles as well. I'll go through this. That's all. Any questions?
So you touched upon versioning, you touched upon header-based versioning.
Right.
Why didn't you talk about like URL-based versioning? So a lot of big APIs should go that way there rather than.
They don't have multiple URL-based versions. They just, like Twitter uses api.twitter.com/0/. There's no /1.
Commands.
Do they use zeros and ones?
They use 1 point something.
I'm not aware.
3.1.
Twitter uses /0,
Yeah.
and there's one Foursquare I think uses V1, V2, something like that. But they don't have both V1 and V2 active at the same time.
I think there's still quite a lot of big players that have multiple versions running at the same time on different URLs.
You could end up in problems with denormalization when you do that. You won't know who is accessing which model. Is it version 1 or is it version 2, and something like that. So use URL-based versioning only when you are making a huge pivotal change that affects. That means you're no longer able to fulfill your V1 clients. Use URL-based versioning, because like header-based versioning, model-based versioning kind of suffices most of your often changing fields in your database, and it's quite easy to implement that as well. You usually have a factory class called say profile, and say profile.get profile object of 1.0, and it gives you a profile object. And then you fill in information into that profile object from your database. So profile.fill user, profile.fill tweet, profile.fill retweet. And these methods, what they do is they go to the corresponding databases, fill self with that information, fill this object with that information, you this pointer or whatever with that information. Once you fill it, you serialize it back. And if version 2 client request comes in, you say something like profile.get object of version 2, instantiate it, and call the necessary methods to fill information. It's a classical use of abstract factory design pattern.
I can see that working very well for like getting data, but when you're updating data, you're going to have to change controllers to have a lot of if statements.
Yes. At that case, you have to have controller-based switching.
You have to be messy. Isn't it better to just have namespaces for different versions and just duplicate your code and make the changes that you need to have?
The other way to do it is.
I would basically. Sorry, I'm a Java developer.
Okay.
Right. And actually, I'm developing not in Java these days, but in Groovy. Or in Rails rather. And I would handle the situation not by doing more controllers. I would add a filter, which is sort of a controller in front of a bunch of controllers.
Exactly.
So you would filter the request as it comes in and dispatch it to whichever other parts of the code it needs to handle. So you still have one entry point for this version, one entry point for the other version, and then dispatch accordingly. I wouldn't build more controllers.
Well, you're still building more controllers. You're dispatching to other pieces.
I would build a back-end middleware that actually dispatches the controllers.
You can also have multiple routes, like version 1 URL endpoint hits this method in your controller class, version 2 hits this method in your controller class, something like that. That is also possible. And the main responsibility of an API server is to abstract database away from the client, from your iPhone or from your Android or whatever client. Okay. I've seen some APIs like this. For getting information from a user table, call user.php. For getting information from profile table or from tweets table, call tweets.php. That's not going to work at all. That's not an API server at all. It almost functions. Instead of using that server, I can install MySQL driver on Objective-C and directly call it database. Right? Doesn't make sense. It's more easy to develop a MySQL database driver on Objective-C and put it into my code, directly call select star. I think something like that should be available, I'm not sure. You shouldn't develop your API like that. Denormalization is a very critical part of your API's design. And second thing is caching. Without these two, it's not an API server at all. It's like it's just a PHP file that sends a bunch of JSON information. Any other questions?
Do we know any tools to document your APIs?
It depends on which language you use. And like for example, when I was developing for one of my clients, he used a Java-based framework called Play, and it automatically helps documentation. And most of the tools, like if you're using Ruby, your tools will support documentation properly, right?
There's also a pretty great one called IODocs, which is written in Node. You configure it based on a JSON file, and you just structure method names it.
Okay.
It automatically gives you documentation in a console where you can test your APIs.
Right. For PHP, there's something called RESTful. It's written by someone from Singapore, a friend of mine from Singapore. It's pretty good. for PHP. It works only for PHP. I mean, it depends on the kind of language you use. And server developers, they usually choose the language in which they are proficient in, implement their server. Right? Any other questions? Okay.